Fine. Today in this session we are going to talk about one of the important feature of plant simulation that is called as a value stream mapping. In actual value stream mapping is nothing but see this diagram. With this diagram you will be having a clear idea. So like I already told you from the day one, from starting in the plant simulation, this green will be representing the mission working status here, the working of the machinery. Whereas this yellow is called as a blocked phase. What is the blocked phase?
Waiting for resources
Okay,
or
waiting.
slot.
Yes, waiting for the mission to do its operation. That is called as a blocked phase. Now, this what is this waiting phase then? There are so many greens here. What a grace.
Like the machine next to it has not completed the given process, so it is waiting for this product to go there. Like the assembly line is stuck.
Okay. Then what you are saying it is almost similar to the blocked only. Then what is the difference between these two, blocked as well as waiting?
So blocked may be the failure due to the failure of machines. So at that time, particular item must be blocked, and waiting means like WIP inventory.
Okay, it's not that one. I will explain you. Okay, there are one, two, three, four missions. Four missions are connected in a line. Okay, this is called as a product layout. In this product layout, a product is entering here. Okay, each end, this output need to be this input. Similarly, the complete finally you need to collect the output. Now all the missions processing time is nothing but a working time. Okay, all the missions processing time is 2 minutes. If it is the same, then what will be happen? A part will be entered after 2 minutes, it will be entered here, after 2 minutes entered here, after 2 minutes entered here. After this one it will be continuous process, which means there is a part with this mission, there is a part with this mission, there is a part with this mission, there is a part with this mission. After first cycle it is like continuous. Now if the processing time differs, let us take an example. This mission is having 2 minutes, this mission is having 5 minutes, 5 minutes, and 2 minutes. Now, there is a conveyor here. For every between these mission stations, there is a conveyor one. This is C1, C2, C3. These are 1, 2, 3, and 4 missions. Now, what will be happen? A part will be coming to the first mission. After 2 minutes, the part will be entering into second mission. Right? Then what will be happen after this? What is the processing time of this mission? 5 minutes. So after 5 minutes only, the second mission is going to produce a part to the third mission. In between, what will be happen between one and two? Clear so far? Or do I need to explain again?
So one more time, please. वो
Okay,
आपका माउस बीच में दिख नहीं रहा था कहाँ पे जा रहा.
fine, fine, fine. I'm just searching for the white screen. Right, the white screen is not visible here. Okay, fine. Okay, there are four missions. First mission, second mission, third mission, and fourth mission. Just a second, what happened? Is it visible? I have erased all those things. I started a new one.
No, sir.
Yes, sir.
No sir.
Wait,
Erased one वो पहले वाले ही दिख रहा है सर.
wait. Let me check why this is not. It's a network glitch. Okay, it was disconnected. Give me a second. One. I hope it's visible.
Yes, sir.
Yes, sir.
Okay. Now I'm having four missions. One, two, three, and four missions. And there is a conveyor between 1 and 2. Same with this one. And same. This I will call as a C1, C2, and C3. Okay. Now the case one, first case. First case is all the missions having processing time 2 minutes. Now what will be happen? A part, there is a input here, and here we need to collect the output. In the first cycle, the part will be entering here. After that, after 2 minutes, the part will be entering here. After 2 minutes, the part will be entering here. After 2 minutes, the part will be entering here. Which means after first cycle, all the missions will be having a part. So whenever there is a 50th part produced here, after that, after 2 minutes, it will be entering into this mission. In this, what will be happening? The 49th part was processed, and the 49th process is going to enter into third mission. Here 48th part was processed, here 47th was processed, which means every mission is having a part, and for every 2 minutes there is a new part that is entering here. There will be no any waiting, there will be no any blocking in this case one. Now there is a case 2. Case 2 is having different of processing times, multiple processing times. This is 2 minutes of processing time. This is 5 minutes. This is 5 minutes, and this is 2 minutes of processing time. Now what will be happen? After the part will be entered here. First part will be entered into this. Just a second. Okay. First part entered here. After that, what will be happen? After 2 minutes, this part will be entering into second mission. There is a part here. Okay. Now, what is the processing time of second mission?
5 minutes.
So, which means after 5 minutes only, the second mission will produce a part, right? So, it will take 5 minutes to produce a part here. In the meantime, what will be happen in this one between 1 and 2?
Sir, a product will wait until the 2 is finished so that it can go to the 2.
Okay, so after 2 minutes, again another part will be coming here. After 2 minutes, there is one more part here. So these two parts are waiting. This is called as a blocking phase. These two parts are waiting for this operation to done or the mission to pick this part. So this is called as a blocking phase. Now, okay, this application was done. After 5 minutes, this part will be entering into third mission. Okay, same. Similarly, there is a law, continuous preparation of material will be there. Why? Because this processing time is 2. Now in between these two stations there won't be any blockage. Why? Because for every minutes a part will be produced and it will be given to this one. So or every 5 minutes, whenever this power mission was done, so part will be entered here. Now what will be happen between 3 and 4? After 5 minutes of processing time here, a part will be produced and given to fourth mission. Okay. What is the processing time of fourth mission?
2 minutes.
So this fourth mission will complete the operation in 2 minutes. Now what will happen to the next 3 minutes for this mission? There won't be any output. Why? Because the mission processing time of third mission is 5 minutes. For every 5 minutes there will be having only one part. So, but this fourth mission processing time is 2 minutes, which means in 2 minutes the part will be completed and it will be given to the output. But this, what happened? Today there is a network error, I hope so. Sorry guys, I don't know why today there is a complete network lost. Okay, fine. Where are we? Now between 3 and 4, what will be happened? There is a conveyor here that is called as a C3 conveyor, and this mission processing time is 5 minutes, and fourth mission processing time is 2 minutes. For every 5 minutes there is a part that is coming from third mission to fourth mission. Now what will be happen to the rest of the time for this mission? Clear first of all what I am trying to say?
Sir, it has to wait for some 3 minutes.
Okay, it has to wait. How much time it will going to wait?
3 minutes.
Okay, so if there is a cycle, if I want to produce 1000 components in this line, now what will be happen? Then I will get these type of charts. This type only half percent charts. Why? Because see there is a limited working is there, and what will be happen of between 1 and 2 there is a lot of blocking phase. Why? Because this machine is having a part, and there are a lot of materials that are fixed on this conveyor, and if the length of the conveyor was full, if the capacity of the conveyor was full, then what will be happen? This there will be an impact on first mission. Then this is called as a blocked phase, that is nothing but yellow phase. Okay, waiting is nothing but this condition, which means the mission is kept idle and it is waiting for the workpiece. That is called as a waiting phase. Okay, waiting and blocking are both are different phases. Both are the failures for an process or failure for a plant. Blocking is for mission, waiting for the mission. Waiting is for waiting for the workpiece. Clear?
Yes, sir.
Okay. Now green was done, yellow was done, gray was done. Now what is the red indicates? Failure. If this one out of 4 missions there is a failure, I have given for every 2 minutes or for every 1 hour, the fourth mission is having 15 minutes of failure or breakdown, then I will get these type of things. For every mission there will be having a failure, so that will be depends on this red color. Okay, this is up to this we will be getting in the plant simulation. Now what is this blue color? There is a paused and there is unplanned. Now what are these two? Hmm? What would be these two? Paused as well as unplanned.
Pause. We can say that suppose there is any failure in any machine, so our work will be paused because of that.
Okay. Then what will be happened if there is a pause in this mission, or if there is a pause on ninth mission? Then the pause should be from this. Then why there is a pause from starting initial? And this pause is a blue phase, dark blue. See here, there is a limited space. Then what is this unplanned?
So maybe because of that means failure, the further things get changed. That will be unplanned. So maybe the failure would be that type. We have to change many things.
If there is a failure, then it will comes on this red path only. If there is a sudden failure, or because of the failure there is a lot of process dependence on it, then it will comes on this red phase. Complete red will be there. Okay, I will explain you here. That is called as a value stream mapping, which means the plant simulation is a library purports the users to taking into dynamic relationship of a complex manufacturing sequence and increase the share of value added production, variability, quality, speed, and efficiency while reducing the inventory. What is value stream mapping? Value stream mapping is an established method for studying of economic value added in the manufacturing for identifying, reducing, and eliminating non-value added process and operations. What is this non-value added process? This non-value added process is nothing but that blue phase, light blue phase. Not is this what is this non-value added processes? If a machine is there, okay, I want to, there is a continuous power supply for 24/7, which means for 24 hours there is a continuous power supply is there. Now out of which I have defined a cycle, I have started a cycle. That cycle starts from morning 9 to 6. Okay, this is the actual time, this is where my production will run. So from morning 9 to 6, in this morning 9 to 6 what will be happened? So there will be having some working phase, there will be having some blocking phase, there will be having waiting phase, there will be having mission setup, there will be having some program setup, there will be having voice setup. At the final thing there will be having a failure also. These many things were involved, but the machine is not going to on at 9 and not going to off in the 6. This machine is having continuous power supply, which means it is starting from 000 and ends at 000, which means it is in a continuous power. It is having continuous cycle. Then what will be happen at this time? This machine is in ideal condition, which means there is no any useful work is happening. At the same time, it is not in a switch off mode. It is not going to turn off. There is a condition that we can't. Some missions there will be having. We need to run the missions, or we need to set the missions in on condition, so that whenever it is necessary, we will run the mission. If we off the mission, what will be happen again? When we're starting, we need to do lot of initial things, like setting the home, setting the there is a what is this G54 is there, what we call it as a, I hope you know cam language, right? CAD cam language.
No, sir.
Okay,
No, sir.
fine, no
No,
problem.
sir.
Then what will be happen? There is a for every mission there is initial home is there, default home is there. Whenever we are going to off the mission or whenever we are going to on the mission will come to this path and it will going to off. Now there is one word called as a what exactly we call it as a, there is a code called G54. Just a second, G54 CNC code. Yes, work coordinate system. We'll call it as a WCS. This is called as a home and this is called as a work coordinate system. These two are different for any mission. If there is a milling mission is there, the milling mission home is like Z at this location and bed at this corner, X and Y at this corner. But this is my home position, I will say. But my WCS would be like my bed will be at the center of the table and my tool will supposed to be at an height. Okay, fine. Okay, my tool will be at supposed to be at a height so that the part will be supposed to fix instantly. So this is my WCS. WCS is like a position where we are going to start our work is WCS. Home is like the mission where it will going to stop or it will start from the initial run. And again there is a difference between home as well as WCS, that is called as a G54 in programming language, work coordinate system. So that what will be happen whenever the machine I need to stop, it will comes to this position, it will be going to end. So for the next run what I need to do, when I on the mission I need to again recenter this one. So I need to create a programming, I need to go to this location, I need to go for manually and I need to give the G54 command and I need to set the programming, that is called as a G54. Definitely this G54 coming to WCS, it will take some time, at least maybe 5 minutes or 10 minutes or 15 minutes based upon the mission complexity it will be getting. At the same time, there is a part that is coming. Okay, that part will be having, I mean we have programmed in that manner so that the part will be supposed to fix at the G54 which we have given. So if I have changed the G54, there will be having lot of things, G54 1, G54 2, G54 3, like different G54s also we can, I mean work coordinate systems we can create. So if there is a slight delay in that, what will be happen? The complete program will be collapsed. That is why majority of the missions will won't switch off after particular time. It will be in a running state, but it will be kept in an ideal state. So which means the spindle is going to stop and everything will be in a stopped condition, but the machine is having a power supply and everything is there. The machine is at G54 location. So if I stop this one, then there will be a lot of things. That is why I will be kept on. So what will happen if I kept on? Then there will be a lot of time, 0 to 9 hours, and after 6 to 12 hours, they will be having this much of unplanned time. Because of this unplanned time, we will be getting this. We can't say that the machine is not working, so we can't give the power supply. So the machine will obviously it will observe some sort of power, some sort of facilities, some sort of resource it will be utilizing. So because of which there will be having a complete data. So this is what exactly unplanned as well as paused. Paused is like whenever I am going to operate a machine, so I want to inspect it at the middle of an operation, at the middle of a component. I want to check the surface finish. I want to check the how exactly the dimensions are coming. So that is called as a paused phase, which is nothing but a dwell. In machine language, we will call it as a dwell, which means a mission pause. So we need to give this command, so automatically the mission will be paused at that condition. We are going to open the doors of the CNC machine and we are going to inspect it. Once the inspection was done, again we are going to run the mission. So that this is called as a pause. This is a program given. But unplanned is like the machine is not having any operation involved in it, but the machine is in on condition. This is called as unplanned. So this will be also a failure for the industry. This is why most of the industries were run continuously 24/7 with different shifts to eliminate this process. Clear? This is called as unplanned. If you try to monitor this one only, if at all you want to run a mission for only 6 to 9, then if you collect a chart, then you will be having this type of sheets. And if you run the mission continuously for 24 hours, then you won't be seeing these blue color bars. Why? Because we have given continuous mission and there is a power supply and mission is running for 24/7, then there is no need of visual seeing this blue color unplanned thing. Why? Because the machine is having a green phase, yellow phase, block phase. With this only, the 100% will going to fill. There is no any particular chance for this blue phase. If the machine is run for only particular time, and if we are giving the power supply to continuously to the machine, then the cycle will be having, the chart will be having this unplanned phase. That is what exactly it is describing. Value streaming mapping is a modern method of process optimization based on the method of lean management. Goal is to easily and quickly map better understanding of value chain for purpose of optimizing it. If at all there is a chart like this, then how can I supposed to optimize? Definitely I'm going to increase the production rate, or definitely I'm going to increase the number of working hours, so that what will be happen, this blue phase will be eliminated. If the blue phase is eliminated, what will be happen? Definitely my production rate will be going to increase. This is called as a value stream mapping. Clear?
Sir,
Yes.
yes. Sir, actually, my side network was lagging. So initially, which you explained about that value stream mapping chart, previous slide.
Hmm.
So initial ones were not that much clear. So can you shortly explain?
Okay, fine, I'll explain you. See, this is a, if at all, let me erase everything and in simple I will explain you. There are three missions. Okay, there are three missions in the plant I am going to prepare. Uh, for these three missions, I have given assigned work from for 6 hours only a day, 6 hours a day, which means 6 hours, 6 hours, 6 hours. So I have collected the charts. So mission resource charts, which means I want to check how exactly the process is running. Then there will be having three bars. Out of these three bars, I will be getting this type of data, which means green will be like this, blocked will be like this, waiting will be like this, and red will be like this. And there will be having a blue phase. Similarly to this one, if you collect these three missions, then it will be like this only. Then why this blue color is nothing but, so we are using these missions for 6 hours only, but we are giving input, I mean power supply, all the things for 24 hours. So what will be happen for the rest of the time? For the rest of the time, the machine is having, the machine is utilizing power, the machine is utilizing every facility that is needed to run the mission, but it is not utilizing. That is why there is called as an unplanned phase. This is called as an unplanned phase. Now, based upon the condition I have explained starting, if there are three missions and if the material handling time, if the processing time is same, then there won't be having any blockage as well as waiting phase. If there will be having a time differ in the processing times between these missions, then what will be happen? Automatically, you will be having blocked as well as waiting phase. Blocked is nothing but A machine is producing a part continuously. This is having 2 minutes of time. This is having 10 minutes of time. Which means what will be happened? For every 2 minutes, this machine is going to produce a part, and this conveyor is having full of parts, whereas this machine is going to produce only one part for every 10 minutes. So for every 10 minutes it is producing, giving you an output 1 2 3 like this. But in the meantime, what will be happening? There is a lot of material that is stagnated in the conveyor because of the capacity. If the capacity, conveyor capacity is having 10, so after the 10, what will be happened? This will impact this machine. Like, this machine is produced the part, and this part is supposed to enter on the conveyor, but this conveyor is having full of capacity. The capacity of the conveyor is 10, so it is not going to accept any other part. So what will be happen? The part will be at this machine only. Now there are input that are waiting for the operation. At the same time, this machine is blocked with this conveyor. If the one part will be entered here, automatically this part will be entered here. Again, same thing. After 2 minutes, this part will be waiting for the next 10 minutes or next 8 minutes. Why? Because the capacity of the conveyor was full. This was happened because of this machine. The processing time of this machine was more. Because of this conveyor was, the capacity of the conveyor was full. Because of this, it was impacted on the first mission. This phase is called as a blocked phase, which is nothing but the mission is waiting, the part is waiting for the mission. When the part is waiting, then we'll call it as a blocked phase. There is one more condition. If the machine is having 10 minutes of processing time, and there is one more machine, it is having 2 minutes of processing time. Now there is a conveyor that is connecting between these two stations. For every 10 minutes, a part is coming here, and it will be going to this station. And for this mission, I mean, this is B and A. The B mission will be having 2 minutes of processing time, which means a part is coming to the B station, and after 2 minutes it is giving the output. But what will be happen? For the next 8 minutes, this mission will going to wait for the workpiece. In the next 8 minutes, again a part will be coming, and this will going to process, and it will give the output, second output. Again for the next 8 minutes, this machine is going to wait. This is called as a waiting phase. Waiting phase is nothing but the machine is waiting for the workpiece. That is called as a waiting. Blocked is nothing but the workpiece is waiting for the mission. That is called as a blocked. Blocked will be represented with the yellow, and waiting will be represented with the gray. Both will be problems for an industry. So even we can manage this gray, this is acceptable, whereas this yellow phase, blocked phase, is not acceptable. Why? Because a part was processed and it is waiting for the mission, which is no way acceptable. If the mission is waiting for the part, maybe that is acceptable for industry, but this yellow phase is not acceptable for the industry. That is why industry will always try to reduce this one. This is called as a blocked phase, or we'll call as a bottlenecks or work in progress. All these things will be denoted for this yellow phase only. Okay, clear?
Yes, sir.
Yes, sir.
Okay. So this is up to this is what exactly I'm going to give you the basics on the plant simulation software. So these are the basics. I mean, these are the information which you need to learn before starting the software itself. Those are the important things I have defined you. Now, benefits and features. I hope I have explained you all these things in the previous day session also. So there is no need of these things. Now, one more important thing, which means where exactly we are going to use this plant simulation. Now, what are these case studies? What exactly describes this word?
Previous examples where the simulation are used.
Okay, previous examples where the simulation is used. Correct. Case study is like nothing but application. If some company is using this plant simulation software and they have come overcome their problem, then we'll call it as a case study. We'll use this as a reference and we'll call it as a case study. Okay. Here, some of the companies are already utilizing this plant simulation software and they have given their statements on all these things. Okay. With this plant simulation, time delivery, more efficient, continuous improvement, this will be definitely expecting from this plant simulation. Now I'll explain you some things. Uh, like I already explained you on the day one or day two, this plant simulation is not only limited for industries. We can do, I mean, we can use this plant simulation for any component or for any organization, for anything we can do this plant simulation software. In Russia, there is a plant, I mean, there is an airport that has utilized this plant simulation software for increasing its operations. See, in 1999, There is an airport from the Russia that is utilizing the Siemens PLM software for the technology as well as reconstruction program. The effective plan of the airport is to renovation, qualitative and quantitative efficiency indicate need to be set. In addition to that, equipment, floor space, transportation requirements need to be determined. This airport is an advanced computer-aided design, CAD tool. Some of the best practices airports that is used for this one, and strategic tools that will be used for the PLM software. The first assignment for Technomatics was a cargo handling simulation project. See, handling, which is nothing but logistics. Cargo handling is nothing but logistics. The objective was to model the handling incoming air cargo in order to identify bottlenecks to improve the overall efficiency. This is what exactly they have created by using this software. They have created the complete layout and they have checked on different areas. So like how the material is moving between stations. I mean, there is a logistics, which means the airport, if the flight is coming from a station, I mean from a country, and it was reached to this destination, after that what will be happen, there is a baggage that need to be collected from the airport and it need to be distributed to the customers by some vehicles from airport, I mean from the aeroplane to the aerodrome. After that what will be happen, there will be having some belts. On that belt they need to distribute the material. How this was happened, so what will be the time rate, how much time it will be taking for this material movement. After that, in the peak hours, how the human will be there, there will be having lot of humans involved in it. The incoming passengers, outgoing passengers, how the traffic will be controlled. After that, there will be having some of the components, like there will be having food facility, water facility, all the things they need to um, serve to the, I mean, airplanes. Then how these material logistics will be happen, how they will be managing all the things. They have used this plant simulation and they have created a virtual models, and they have succeeded using the plant simulation model. They have modified the model passengers within the terminal. Airport experts were able to experiment a variety of scenarios to evaluate and determine the optimal approach. Peak loads were the special concern, especially related to the equipment needed to handle in high traffic times. Plant simulation accounted for the different passengers' flow pattern, considering both incoming and outgoing schedules. Bottlenecks are readily revealed by considering this one. Again, these are some of the words on this management. So they have overcome many type of scenarios by using this plant simulation in that airport. Okay. Now, one more case study is from the Comau, Shanghai. This is called as a robotic manufacturing company. This company will generally supply the robots to the industries. I mean, to the supporting industry, manufacturing industries, or continuous industries. This plant is itself preparing their own robots, and they are utilizing these type of software, technomatic tools like plant simulation, robotic simulation, process simulation for overcoming their problems. Like this is industry is a machinery and equipment. Business challenges acquire both domestic and foreign automotive, and expanding new areas to such as aerospace. Use technomatic plant simulation software to validate production plans, leverage global technologies and process designer and process simulate softwares. And with this one, they have increased their. These are the achievements which they have achieved by using the software. And see, this is how exactly they will going to produce a model, and after preparing a virtual model, how exactly it will be looking in an actual model. See, a physical commissioned welding station delivered at Fiat Automotive, and a virtual working cell by using Technomatics. This is what exactly they have created by using the software. Once it was working perfectly with all the robots, with all the programming which they have defined in the software, then they will implement into the actual shop floor. See, same, everything is same. There is no any change in between these two. All the material handling devices, all the conveyors, all the lifts, cranes, all the human passages, everything was same. Okay. And one more thing, I hope you know this one. BIW, we'll call it as a body in white assembly, which means what will be happen? This is a section where the car parts will be assembled, where the chassis and the skeleton of the body will be assembled. Which means here from this station the chassis will come, and from this station the side panels, two side panels, and this side two side panels will come. These robots will pick these parts and place at a place at a location where, by the help of, these are called as the jigs and fixers. By the help of jigs and fixers, the automotive will going to hold at this position. Simultaneously, these spot welding robots, they will do the spot welding. We'll call this as a body in white. Not only this company, every company follows this assembly as a body in white assembly. So most of the companies will use robots, process simulation software, robotic simulation, plant simulation software for this type of perspective only. Why? Because it is a continuous moving process. In a continuous moving process, how we are going to manage, so how exactly we are going to see the process, how much time it will be taking, from where the parts need to be collected, and how the parts will be managed exactly. So what will be the tolerance, what will be the errors that need to be maintained, what is the accuracy that need to be identified, all those things we can we can visualize with the help of this plant simulation software. Okay, see, this is some of the workstations which they have created for these robots. Some companies will be having lot of robots like this. This company itself is preparing robots, so it is having large number of robots for doing each and every operation. Some company having limited number of robots. Some company will be having more number of CNC machines, limited number of robots. Based upon the availability of the machines, we can prepare the layouts. We can prepare the components. See here, this is a separate layout. The rear floor welding at the line station by using Technomatics. Okay, I will show you a video. I hope the video is not visible here. Fine, no problem. Just a second. Just have a look on this video. You will be getting clear idea on what exactly this simulation software is.
The Chinese market represents a huge opportunity for Comau China. There are only 45 to 50 cars per 1,000 people in China currently. In developed countries, this ratio is significantly higher, so the opportunities in this market are huge. One of our advantages as a line builder in the Chinese market is that we are really a global company. A global line builder, as we say in Comau, global strategy, local execution. Looking forward, I can foresee that our global operations will leverage the excellent knowledge and skills we are developing.
This team must deliver value. For example, in 2011, our biggest project was a completely body-in-white line for Fiat China, which included around 250 Comau robots. 20 engineers worked on this project using Technomatics tools for nearly half a year, and the delivery state line and hard simulation that support the production line, which is now in operation. This project proved our ability to collaborate across continents, and we use some welding guns that were designed in Italy.
Process Designer 和 Process Simulate 还为写标书打下了一个良好的基础。我们已经提交了几份基于这些解决方案的标书，我们相信这种方法将会日益普及。
We currently employ the biggest and best skilled 3D simulation team in China. Dozens of engineers who use RobCAD, Process Designer, and Process Simulate. The Technomatics tools not only help us to provide best-in-class production lines to our customer, but also help us to eliminate waste in our engineering and helping minimize rework on the shop floor.
Compared to a project done using RobCAD with Process Designer and Process Simulate, I see a clear saving in engineering manpower. Since there is no need for a Comau Shanghai engineer who function as a technical mechanical leader to be involved in this communication. It's straightforward to communicate directly with customer based on Process Design and Process Simulate data. Most of our customers require us to use tools in Technomatics portfolio, such as RobCAD, Process Design, and Process Simulate. But even for those few customers who use other tools, we have taken the strategy decision to use only Technomatics toolset. Why? Because we believe Technomatics is the best tool for set the 3D simulation and the robotics work shells. Using Technomatics tools, we are able to simulate more production scenario in a very short time. Now we are about to simulate and commission in the second phase of this project, which almost double the line through by means of cycle time reduction and the multiplication of the robotic station. For a line builder like Comau Shanghai, the engineering communication framework with the customer is always a challenge. What form of communication to use, which data to share with customer, and how to frequently to do so.
随着需要提供模拟数据客户的日益增多，我们意识到要提供一个更加灵活的系统架构来支持不同客户的需求。它包括 Process Designer 和 Process Simulate 的版本、数据环境和软件环境。因此，在西门子 PIM 软件的支持下，部署了一个虚实相结合的软件创新环境。该配置节省了60%的硬件成本，提高了硬件的利用率，并使信息部有能力在3天内为新的客户或项目提供全新的 Process Designer 和 Process Simulate 的软件环境，大大提高了信息部在企业内部的满意度。
另一个具有前景的领域是 Team-Centered Manufacturing Process Planner 与 Process Simulate 的整合，因为它能让我们使全球各地的库和工艺计划克服组织结构和地理方面的各种障碍。科马上海正在研究西门子 PLM 软件的其他前景广阔的制造工程解决方案，例如 Process Simulate Virtual Commissioning， 利用真实的控制器测试虚拟作业单元是一个前景广阔的领域，因为它能够缩短项目工期。它还能涉及一些公司结构方面的变化，因为现在属于另一个部门的控制工程师必须与模拟工程师展开紧密合作。
We are already a market leader in the areas of automotive body welding and powertrain machining and assembly. We're experiencing a very fast growth to the excellent engineering skills we have developed, our relentless efforts for continuous improvement, and the big value we deliver for our customers. This would not have been possible if we were not using the tools of Technomatics.
This is one of the case study. Okay, now coming back into the session, this simulation software is also capable for the food as well as beverage industries. Like already told you, this is they will be having a lot of features that will be work for the fluids as well as liquids, some type of semi solids also. So in that we're going to work with the different food as well as a liquid type of industries where they use different more materials as inputs. With this, definitely they are going to increase their bottlenecks. I mean, identify and fix their bottlenecks, develop optimal cleaning strategies. They can try to increase their percentage. They can try to increase their efficiency. These are the different approaches for which food and beverage manufacturing industries will look like. Third part will be this plant simulation is also capable of doing improvements in warehousing and logistics. Warehousing and logistics is nothing but once the output was ready. Okay, once the output was ready and I am having some 10,000 parts of output. Now where I need to dispatch, how I need to dispatch all those things, where I need to store. So once I have stored all the things, so how I need to dispatch the material, whether I need to dispatch in first in and first out or first in last out, like what is the procedure I need to adopt or follow for dispatching or for the delivering those products. I need to prepare some schedules. For the schedules we can use these type of softwares for the material movement between the stations. Let us take an example. There is a truck here and there is a lot of material here. How the material need to be collected from the station, what is the path that this forklift need to adapt after this first path. Just a second. After the first path, how this, where is this one? Oh, yes, after this first chamber was done, then which chamber it definitely go to, whether it need to go to this one or this one or this one, like what is the type of procedure that need to follow, what is the algorithm that they need to follow. So what is the capacity of the forklift, once the forklift was full, how it need to go. So this, see, there is a yellow line here, yellow line. Based upon the yellow line, this forklift automatically trace that line and it will go to the desired location which it was given, and it will go to that location. It will dispatch the material, whether it is a truck or whether it is in some container or storage area, that doesn't matter. But based upon the program which we have given to this AGV or a forklift, then automatically it will work. If it's a human operated one, then he will do the same task. So this plant simulation is also capable of doing this warehousing as well as logistic applications. Okay, just have a look on this video also, then you will be getting clear idea on what exactly this software is capable of. Where is this one?
This video gives you a brief overview of the virtual simulation case of Dolciana Chocolates. Dolciana Chocolates is a manufacturer and distributor of luxury chocolate products with over 150 years of chocolate experience. Dolciana supplies the European market from a single European distribution center. This distribution center is a highly automated facility with over 20,000 pallet positions, automated cranes, and handling robots. Let's check on Dolciana's inbound pallet flow. All chocolate and candy products of Dolciana, which are not locally produced, are shipped to the distribution center in the morning by trucks. When a truck arrives at the warehouse, then it gets allocated an available dock. A pallet jack picks 4 pallets at the time from the truck and drops them on the staging floor direct behind the dock. A reach truck picks the pallets from the staging floor and brings them to the robot in feed positions. A series of automated conveyors and robots transport the pallet to exactly the aisle where the pallet is expected. The crane then transports the pallet to the right location for storage. Dolciana suffers from huge capacity losses due to traffic pressure within their distribution center. Pallet jacks and reach trucks are sent to the same area all the time by Dolciana's internal warehouse management system. That causes in resources which are constant waiting for each other and therefore long waiting time for pallets and underutilized cranes in the automatic storage and retrieval system. As a result, the left chart shows that the availability of the pallet jack, the blue part of the bar, is less than 10%, while in the right chart is seen that each pallet jack spends roughly 40% of its time queuing in a traffic jam. Dolciana has used plant simulation to solve and optimize these traffic issues. After careful analysis, Dolciana uses teams of pallet jacks and reach trucks now in order to handle the inbound flow of shipments. This means that one pallet jack is responsible for unloading one single truck, and one reach truck is responsible for handling all these pallets from this truck and transport them to the robot in feed position. Dolciana handles more pallets in less time, which makes the system less complex, and most important, there's no investment required. This solution is both simple and elegant, as Dolciana is. As a result, the pallet jack availability goes up to 55%, which saves Dolciana a few pallet jacks, and the queuing time goes down to an acceptable 5%. In summary, Dolciana's solution handles more pallets in less time, in less complexity, and has no investment required.
Okay, so that is one of the case study which I want to show. After that, there is a robotic plant, Coca robots. The Coca robots also use the same thing, like different things, plant simulation as well as robotic simulation. Plant simulation for creating the complete plant, for which they are going to manufacture their own robots by using the layout, by using these type of softwares, and they will create their own robots with the help of robotic simulation as well as plant simulation. So this is what exactly the layout would be, by using the process simulation software, in which they are going to adopt these type of different scenarios, and they are going to involve in the plant. In India, there is a like Mahindra and Mahindra is also company, one of the company which are using these plant simulation softwares, with which they are going to, I mean, these are the challenges with which they are going to overcome, like market competition, and they want to sustain in the market, time to buy market, and they want to give the materials in time. So for which the company needs to follow some set of digital manufacturing software, so that they want to sustain in the market. So because of which they are using these technomatic tools for sustaining the market. As a result, they are getting these things: reduced lead time in overall duration of the vehicle project, decreased capital investments in machine and conveyors, sustainability, shortened lead time, reduced bottlenecks, increased reuse of manufacturing tools, maximized production resource utilization. These are the some of the things they will be achieved by using these plant simulation softwares. And these are the words, I mean, these are the statements given by the management of the Mahindra and Mahindra vehicles. This is how exactly it will be. There is a truck that is coming, and this is the layout they need to create, and based upon the layout they need to program it. So how the robots are going to do the operation, how the part is coming, what exactly it need to do in this operation, all the things that can be monitored by using the plant simulation software. Okay, I hope you know all these things. I have discussed all these things in the previous session also. So that's it from the plant simulation side. Okay, basics of the plant simulation, all those things. Any doubts so far?
No, sir.
Clear, I hope.